Hi guys, the purpose of this is to help provide you with further examples to get ready to take the quadratics performance task. The first problem is given you a function in vertex form. It's asking you to find the solutions, the axis of symmetry, the vertex, y-intercept, and graph using at least 5 points. First thing we need to talk about is how does that differ from the parent function? Remember, the parent function is y equals x squared. So if we put a negative out in front of it, as you can see right there, it's reflected because the a value is negative. It's also translated 4 up and 4 left and up 7. That positive 4 in there makes it go left 4, and then the positive 7 at the end causes the quadratic equation to go up 7. So it's reflected, translated 4 left, and up 7. Also gives us the vertex. Remember, inside it's the opposite of that value, so the vertex is -4, and then the other value of that is going to be 7, so -4, 7. From there, you can get the axis of symmetry. The axis of symmetry is x equals -4. It's just the x value of the vertex. If I were to graph the vertex, I graph it at -4, 7, which is this purple point right here. And then keep in mind the axis of symmetry goes right down the middle of that parabola. Our solutions, in order to get the solutions, the best way to get them in this case is to go ahead and use square root. It's already in vertex form, so we move the 7 to the other side. Don't forget to change the sign. It becomes -7. But now I've got this negative out in front of the x plus 4 quantity squared. We've got to get rid of that. So you divide each side by a -1 to get rid of that sign there. -7 divided by -1 is +7. Now take the square root of both sides. The square root of 7 rounded is 2.65. So you have x plus 4 equals the positive or negative value of 2.65. Set up both of those scenarios. X plus 4 equals 2.65 and x plus 4 equals -2.65. Subtract 4 from both sides and x equals -1.35. Subtract 4 from both sides on this side and x equals -6.65. So those are the two solutions. Those are the 2 points where the parabola is going to cross the x-axis. I graphed those in green over here on the left. So here is -1.35, a little past -1, not quite to -2 yet. And then past -5, there's -6. There's roughly about where -6.65 is. So now you can see that those are directly in between that axis of symmetry. It splits it right down the middle. They should each be equally distant apart. The next thing we need to find is the y-intercept. Remember, 7 is not the y-intercept. This is not in standard form, it's in vertex form. So we have to go and find it. But don't make this more challenging than it is. The y-intercept is whatever y is when x is 0. So we're going to plug in 0 for x and solve for y. Right into the original equation. So negative, and then in parentheses, 0 instead of x plus 4, quantity squared plus 7. 0 plus 4 is 4. 4 squared is 16, but don't forget there's a negative out in front. -16 plus 7 is -9. So the y-intercept is 0, -9. I graphed that right there in pink. Now we need one more point because the graph is asking for 5. If I continue my axis of symmetry down and I'm looking to see where the y-intercept is located, it is 1, 2, 3, 4 to the right of the axis of symmetry. So you can go backwards and go 1, 2, 3, 4 to the left of the axis of symmetry and get the last point, which is at -8, -9, which is what I wrote up here for the other point. Moving on to question number 2. Question number 2 is given us a function in standard form this time, y equals x squared plus 5x minus 14. We have to graph and find the solutions using various methods. The first one is to make a table. For our table, the first thing we need to do is find the vertex. X equals -b over 2a, then we'll plug back in after we get our x value to solve for y. So our b value is -5 over 2 times 1, so -5 divided by 2 is -2.5. I'm going to put that right there in the middle of the table. -2.5, comma -20.25, which I'll show you how to get. Once I get -2.5 for x, that's exactly what I'm going to plug into the original equation. Y equals -2.5 quantity squared plus 5 times -2.5 minus 14. If I square negative 2.5, you get 6.25 minus 12.5 minus 14, which computes to negative 20.25, which is what I wrote up in the table. Notice how I put the vertex there in the middle because everything centers around that. Now I graph my point down here. I'm thinking, man, I need to get something over here to the right. Negative 1 is a really easy number to plug in. So I'm going to plug in negative 1 for x. So negative 1 squared plus 5 times negative 1 minus 14. Negative 1 squared is 1. 5 times negative 1 is negative 5. Take away 14 is negative 18. So I have negative 1, negative 18. That would go right here in the table if we're keeping this in numerical order. If I can graph the point negative 1, negative 18, I can go symmetrical of that. Remember, this is our axis of symmetry if our vertex is right there in red. So I can go 1.5 to the left and get negative 4, negative 18. So those 2 points are equally distant apart from one another. For the last point, you can use none other than the y-intercept. The y-intercept, since this is in standard form, is your c value. So your y-intercept is negative 14. So I use the point 0, negative 14 in the chart. If you use 0, negative 14, you can use symmetrical of that and have negative 5, negative 14. Again, everything is centered around that axis of symmetry. Now, we just actually completed number 1 and number 2 because it asked for us to complete a table and it asked for us to graph. We completed our graph using at least 5 points. The next thing in the instructions are to solve by factoring. So x squared plus 5x minus 14. I'm looking for factors of negative 14 that are going to give us a negative or a positive 5 in the middle. So I need a positive 7 and a negative 2. I can't have negative 7 and positive 2 because that would have given us a negative 5. So I set up my two parentheses, x plus 5 and x minus 2. Now set each of those parentheses equal to 0 because of the zero product property tells us we can find the solutions by setting these two products equal to 0. Subtract 7 from each side and x equals negative 7. That's one of our zeros of the function. Go back to the other side, add 2 to each side, and x equals 2. So the two solutions are negative 7 and positive 2. You can go up to our graph and look at negative 7 and positive 2, and those are going to fit right in line with what we have going on with our graph already. Number 4 says put it in vertex form, complete the square, and solve by square roots. In vertex form, that c value has to go to the other side. So you have x squared plus 5x plus 6.25 equals 14 plus 6.25. The reason I know it's 6.25 is because you take your b value divided by 2 and square it. So 5 divided by 2 is 2.5 squared is 6.25. That goes in for there and then up above as well. Now, don't forget, that's a perfect square trinomial right there that you need to write as a binomial square. So x plus 2.5 quantity squared. Whatever it is before you square it, your value, you can write in there in your parentheses. So x plus 2.5 quantity squared equals 20.25. The 20.25 came from this piece over here. 14 plus 6.25 on the right side is 20.25. One move and you have it in vertex form, bring that 20.25 to the other side. So x plus 2.5 quantity squared minus 20.25 equals 0, or you can always set it equal to y at the beginning. You can double check, is that what we had for our vertex? The opposite of 2.5 is negative 2.5, and then the negative 20.25 at the end. And that's exactly what we had originally for our vertex. Since we're in vertex form, it's so easy to solve by square root. We already had the x plus 2.5 quantity squared equals 20.25, so we can simply square root both sides. X plus 2.5 equals the square root of 20.25 is 4.5, but don't forget, you can solve for the positive root of that and the negative root as well. Subtract 2.5 from each side and x equals 2. Subtract 2.5 from each side for the other half, and x equals negative 7. Whew, this is great because it's exactly what we got when we solved by factoring, the solutions of 2 and negative 7. So just like on your performance task, you can kind of double check and, okay, I think I factored it right, but now you can solve by square roots to kind of double check. I'm still going to expect to see all the work though to ensure that you know how to solve by multiple methods. The last thing is the quadratic formula, your favorite song that we learned in class the other day. X equals negative b plus or minus square root b squared minus 4ac all over 2a. A is 1, b is 5, c is negative 14 from the given equation. X equals negative 5 plus or minus the square root of b squared, which is 5 squared, minus 4 times 1 times negative 14, all over 2a, which is 2 times 1. So x equals negative 5 plus or minus the square root. 5 squared is 25, and negative 4 times 1 times negative 14 is positive 56. There's an even number of negatives, so it's a positive. We add them together, all divided by 2 on the bottom. So now when I add 25 and 56 together, you get 81. So negative 5 plus or minus the square root of 81 divided by 2. The square root of 81 is 9, but don't forget, I need a positive and a negative solution. So negative 5 plus 9 divided by 2 and negative 5 minus 9 divided by 2. Negative 5 plus 9 divided by 2 is 2. Negative 5 minus 9 divided by 2 is negative 7. Once again, we're getting those same solutions that we have been getting from factoring and solving by square roots, so you know that you did it correctly. If you have any questions, please don't hesitate to ask, but you can use this to help you prepare for your performance task.